Okay, so our last chapter we're going to look at is chapter 10. We're going to look at section 10.1 and 10.2. Both sections are on solving systems of equations. Okay, so just as a reminder what a system is, okay, it's when you're solving an equation that has two or more variables. Okay, two or more variables and two or more equations. And specifically for our purposes, the number of equations will always be the same as the number of variables. If there's two variables, there'll be two equations. Three variables, three equations. Interesting things happen when the number of equations doesn't equal the number of variables. Okay, for example, this is an equation. This is one equation, two variables. If that's all I gave you, how many solutions are there to that equation? X plus y equals 12. Infinite. 1 plus 11 equals 12. 6 plus 6. 5 plus 7. There's infinitely many solutions. So if you have more variables than you do equations, that can happen. Okay? So we'll always be looking at the same number of letters as we have equations. Okay, this first one, we're just going to set up the system. Okay, after we set it up, we're going to learn about how to use a method, and then we're going to come back and solve it. Okay, so I just want to set it up. Okay, so I'm telling you about the perimeter and the area of a rectangle. And knowing those two things, I want to find the length and the width. Right, so let's start with perimeter. Does anybody remember the formula for perimeter of a rectangle? Yep.
2L plus 2W.
Right, the perimeter is 2L, twice the length, plus twice the width. Now I can actually fill in for perimeter. They tell me what it is. How much is the perimeter in this problem? Yep, it's 100. So that's my first equation. And if that's all they gave me, there would be an infinite number of answers. I could give you infinitely many rectangles that have a perimeter of 100. But they give me one more fact. The area is 300. Okay. What's the formula for area of a rectangle? Length times width. Area equals length times width. And in Derek, this case, they tell me the area is 300. So that's going to be our system we come back and solve in a few minutes. Notice two equations, two letters. We have an L and a W. Any question on setting up that system? All right. So the two main methods we're going to look at for solving systems here are substitution and elimination, both of which you've probably done in Algebra 1. What's going to be a little different is we're going to extend it to three variables, which usually you don't do in Algebra 1. All right, so basic idea with substitution. Okay, you pick an equation, and you have to get a variable by itself. Okay, so you got two equations to pick from. Pick whichever one is easier, and solve for a variable. Okay, after you do that, you're going to take your result from step 1, and you're going to plug it into the other equation. It'll make more sense when we do an example. You're going to take your result from step 1, and you're going to plug it into the other equation. Okay, after step 2, you're going to know one of your answers. So for example, if you're solving for length and width, maybe at this point you would know the length. Okay, you'll know one of the two. After you have one of your answers, you take that answer, you plug it back into one of the original equations. It does not matter which one. And you solve for the other variable. So after step 2, if I knew the length, in step 3, I'd be finding the width. Right, so what I'm going to do is I'm going to use these steps to solve the equation, the system we just came up with. Okay, so I'm going to go back and I'm going to copy and paste what we had for our two equations onto the next page. So let me just get these real quick. And that's going to be the system we'll solve. Right, let's try to go through it. Step 1, pick an equation and get a variable by itself. Which equation here do you think is easier to get a variable by itself? The top equation or bottom equation? Yeah, bottom equation. You can do one step to get a variable by itself, and it doesn't matter which variable you get by itself. So Tommy Lee, can you tell me what could you do to the bottom equation?
You could divide by either L or W.
All right. So he said divide either by L or W. Let's divide by L. So 300 divided by L equals W. Okay, so now we have a formula for the width. It's 300 divided by the length. Okay, that's step 1. Okay, step 2. We're going to take and plug in what's in this box into the other equation, into the top equation. What letter am I going to fill in, or what letter am I going to replace with what's in this box? Yeah, W. Okay, so now in the top equation, change all your W's to 300 divided by L. And we're going to have 2 times W, which is 300 divided by L. Now, if you look at the equation we just created, how many different letters do we have? We just have, yeah, we have 2 of the same letter, just one letter, just L. Now we're going to solve for L. All right. First thing I can do is at least simplify the numerator. $600 divided by L. Okay. Next thing I'd like to do is try to get rid of this fraction. Okay. What could I do? I'd have to do it everywhere, but it would get rid of the L in the bottom. Yeah, we're going to multiply everything by L. So now we have 100L equals 2L squared plus 600. Okay, because we just multiplied by a letter, when we're all done, we have to check for answers that don't work. Does anybody remember what those are called? Extraneous. Yeah, that's okay. Extraneous, yeah. So we got to check for answers that don't work. Does anybody see what kind of equation this is starting to become? Yeah, it's going to be a quadratic equation. So we'll either have to factor it or use the quadratic formula. Generally, when you do either approach, you like to have your quadratic equation equal to what number? 0. Yep. You want to get everything on one side, get 0 on the other. So I'm just going to subtract 100L to the other side. And I get 2L squared minus 100L plus 600. Okay, now if I wanted, I could make the numbers a little smaller here. Okay, and if I was going to factor, this would be really helpful. What can I do to make everything smaller? Yeah, you can divide through by 2. And I think smaller numbers are easier to factor, or at least try to see the pattern. It turns out this one's not going to factor, but let's still make everything a little smaller. So you get L squared minus 50L plus 300. Right, so now at this point, it's a quadratic equation. We'll use quadratic formula. All right. Somebody remind me what three letters are in the quadratic formula? A, B, and C. What's A in this equation?
L for 1.
1, yeah. How about B?
Negative
50, good. And C? 300. Okay, so now just fill into your quadratic formula. What's the first thing in the quadratic formula?
X equals
Negative B, yep.
plus or minus the square root of B squared
B squared.
minus 4AC.
4AC, so far so good.
All over 2A.
All over 2A. And when we're done, we will know the length. All right, so let's do out what we can. 4 times 300 is 1,200. What's 2,500 minus 1,200? Yep, 1,300. All divided by 2. Okay, at this point, I need my calculator. All right, so let's try 50 plus square root of 1,300. Yeah, I'll just do that part first. And divide by 2. So one possible answer for my length is 43.03. Or, instead of doing 50 plus 1,300, square root of 1,300, I can do 50 minus square root of 1,300. Now, if I get a certain kind of answer, I know it doesn't work. What kind of numbers?
Negative.
Yeah, if I get a negative, I can ignore it. Okay, so let's just try the top and see what happens. Okay, I don't think it's going to come out negative. I don't think the square root's big enough. Okay, so we get 13.94 divided by 2. So we get two answers. 6.97 is the other answer. All right, now that I have my length, let's find our width. Now, if we scroll back up, do we have a formula for W with the W already by itself? Yeah, right in that box. 300 divided by the length equals W. Okay, so just do that for each problem. Let's take 300 and divide by the length. 300 divided by 43.03, look what you get. 6.97. Or, let's take 300 divided by 6.97. What do you think you're going to get?
43.03.
Yeah, you get 43 point, well, due to rounding, you get 0.04. We can write 0.03. So either this is your length and your width, or that is your length and your width.
Isn't it basically like the same thing?
Yeah, it's basically the same thing. It's just whether you're looking at the rectangle horizontally or vertically.
So, can you just say what we found W again?
W?
Width.
Yeah, to find W, we have a formula that says the width equals 300 divided by the length.
300 divided by either 6.7.
Yep. So I did 300 divided by the first length, and then 300 divided by the second length. And it turns out it's the same rectangle, just horizontally or vertically. Any questions on that?
I'm not going to have to figure out which one it is, right?
Yeah, it's both of them. Yeah.
It's either way.
Yeah, it's either way. Yep.
So how can it be both of them?
Well, it's really the same rectangle.
Yeah.
It's just whether you're looking at the rectangle
Yeah, I get it now.
this way or this way.
Okay.
The same perimeter, same area. It's
Yeah.
just- yeah. But technically, those are two different answers, depending which way you look at it. All right, let's try another one with substitution, not a word problem this time, just two equations. All right, so you have two choices. Your first choice is what equation do you want to pick? Second choice, which letter do you want to get by itself? In this case, I think there's definitely an easy equation and an easy letter to work with. What equation should we work with here? Yep, I would work with the top one. And what letter can we get by itself? Yep, we can get y by itself. Okay, so if we get y by itself, Brian, can you tell me what y would equal?
Negative 2x plus 5.
Yep. So he wrote it kind of like thinking about y equals mx plus b. He put the x term first. That's fine. So negative 2x plus 5. Now, what am I going to do with the negative 2x plus 5? Yep. And for what letter are you going to plug it in for? Y. Plug it in right there. Okay. When I plug it in, what do I want to be careful about?
I'm looking 2 minus
2. Yeah, so what could I put to maybe avoid?
parentheses.
Yeah, I would put parentheses, especially because you have a 2 in front of this y, which is going to turn into a distributive property. Okay, so we got plus 2. Now fill in everything for y. Negative 2x plus 5. And now just solve for x. So it's going to be 3x minus 4x plus 10 equals 2. Cameron, what would my next step be?
Combining the 3x and the negative 4x.
Yep.
To get a negative x.
So we're going to negative x. And at the same time, I'm going to move the 10 to the other side. Eric, what's 2 minus 10?
2 minus 10. Oh, that's negative 8.
Negative 8. So x is 8. And now that we know x, we can go back and find
Why?
y. Yeah. And we have a formula right here. Y is negative 2x plus 5. So just fill that in. So y is negative 2 times 8 plus 5. So that tells me y is negative 11. Okay. Any questions on that? Or just substitution? All right. So the other method we can use, some of the time this is quicker, is elimination. Okay. The idea with elimination is you're trying to get variables to cancel out, okay, to be opposites. Okay, and we do that by adding a linear combination. Just means a multiple. Okay, we're going to add multiples of one equation to another equation. Okay, and the goal is to try to get the coefficients to be the same or opposite. Generally, I'm going to try to make them opposite. Okay. Because if you have two numbers that are opposites and you add them, what do you get?
You get 0.
You get 0. They cancel out. If you were doing the same, the idea would be to subtract. You get two numbers that are the same and subtract, it's 0. Okay? But let's just try to get them to be opposites. That's how we'll do it. Okay? And in order to do that, sometimes you have to multiply one of the equations by a number. And when I say equation, it has to be everything. Or sometimes you have to multiply both equations by a number. Generally, we try to avoid multiplying by fractions. Okay, when I say by a constant, I want to pick a number that is not a fraction or a decimal. But you can use positive numbers, you can use negative numbers. Let's just avoid fractions and decimals. All right, so this is a problem where we're going to use elimination. Okay, substitution would work, but the problem with substitution is you're going to end up with fractions when you solve it. Might not end up with fractions in the final answer, but in the process of getting there, you're going to have to try to get a variable by itself. And no matter how you do it, you're going to get fractions. Right, so with elimination, the first step is to pick a variable that you want to make the numbers in front opposites. Okay, so do you want to make the coefficients of x or the coefficients of y opposite? How about Paige? Which one do you want to do?
1, 2, and 3.
So the coefficients of x, right? So we're going to make those opposites. Does anybody see what I could multiply the top equation by to get that process started?
-3. I know. Yeah, -3. Right?
Any reason why you picked a negative, not a positive?
Because, or no, never mind, it would be a positive.
Yeah, I would do you could do a negative, but I would just do a positive. And you said multiply by 3? All right. So we're going to triple everything in the top equation. We're going to get 6x plus 9y equals 15. Don't forget to triple everything, okay? And I'll just put here times by 3. How about the bottom equation?
2.
Yeah, all right, let's try it. So in the bottom equation, we're going to multiply everything by 2, okay? And watch what happens. You get negative 6x plus 10y equals 42. Now we're going to add those equations up. Okay, what do you get when you add your x's up?
0.
Yep. X's are gone. How about when you add up the y's? 19y and 15 plus 42? 57. And last step to get y by itself. Divide by 19. So what is y? 3. Yep. So now the only disadvantage with this is, well, one, we made all the numbers bigger, okay? But we also don't have an equation with y by itself. So now you pick top or bottom and plug y back in.
Does it matter which one?
If you found y correctly, it will not make a difference. Nope. So which one you want to do? Top one. So we're going to fill 3 in for y. And we're going to get 2x plus how much? Yep, 9 equals 5. 2x is going to equal
14.
negative 4. Yep, so remember, we're going to do 5 minus 9. And x is what? Negative 2. Okay, and you can almost think of this as a coordinate, negative 2, 3. Now, these are, what kind of shapes would these be if we got y by itself and drew them? They're just straight lines. Okay? The top one is a line, the bottom one is a line. This point is very significant with the two lines. What would be happening if we were to solve this by graphing? Yep.
They would be intersecting.
That's where they would cross, yeah. Okay, we're not solving by graphing, but if you were, that's where the two lines would cross each other.
Do you think perpendicular or anything like that? Because I don't know.
To find out if they're perpendicular, we'd have to look at their slopes. Okay, if the slopes are opposites and reciprocals, then they would be perpendicular.
So the first part of it being offset has nothing to do with any of it.
No, yeah, that doesn't quite tell us enough, because we'd have to divide by the coefficients of the y to get y by itself. So the slope on this top equation would really be, if we got y by itself, you'd have negative 2x plus 5, and then you'd have to divide everything by 3. So if the bottom equation came out to a slope of 3 over 2, they'd be perpendicular, but it's not going to. So no, these are not perpendicular. Okay. Any Any other questions on that? Right. So if you think about solving a system in terms of graphing, this will tell you the three types of things that could happen. Okay. Think about drawing two lines. Okay. One thing they could do is what we just said. They intersect exactly how many times? Once. Okay. They cross each other one time, and you get a solution right there. What's something else that could happen if you draw two lines? They could not cross at all. They could be parallel. And what would that mean about the number of solutions? There are none. Right? So it's possible you could have a system when you go to solve it. Graphically, they would be parallel lines. They'd never cross. And there's one more thing that can happen.
They cross multiple times.
And what would that mean?
Is there more than one answer?
Yes. How can lines cross multiple times?
They're parabola or something like that?
Well, they're lines, so they're not curved.
It'd be infinite, right? Because they'd have to be on top of each other.
Right. It'd have to be the same line. Two lines right on top of each other, they cross infinitely many times, so you have infinite solutions. Now, if we started to get into something like a parabola and a line, then you could say, well, you could have something like this. It crosses twice. Actually, I'd have to do it like this. Parabola goes up forever, but it never goes down, so they don't cross at all. Or it could cross once. Okay, so you'd have different cases depending on the shapes. But these are the shapes for linear. Okay, or these are the cases for linear. All right, let's try this one with elimination, and something different is going to happen here. What could I multiply the top equation by to make a letter cancel out?
3.
Yeah, let's multiply it by 3. Can you tell me, Eric, what that'll give me?
6x minus 9y equals 15.
Okay, and our bottom equation, negative 6x plus 9y equals 10. What do I get if I add my x's up?
0.
My y's?
0.
So I get 0 equals, what's 15 plus 10?
25.
Okay, 0 equals 25.
No solution.
That's no solution. So if all your variables cancel out and you end up with 0 equals something other than 0, that's no solution. Okay, what would happen if, let's say after I multiplied by something, actually, you know what? I think I'm going to have that in the next, we'll look at that in the next problem. Okay, so any question why there's no solution? These would be parallel lines if you drew them. They have the same slope, different y-intercepts. Okay, let's try this one. What could I multiply the top equation by here?
2.
Yep. Multiply by 2. We get 2x minus 6y equals negative 4. Negative 2x plus 6y equals positive 4. If you add up the x's, what happens?
0.
Y's? And negative 4 plus 4? All right, a little different. This is infinite solutions. These are the exact same equation. The top one and the bottom one, there's no difference between them. In fact, if I had multiplied the top equation by negative 2, then that would show you they're exactly identical. So these are the same line right on top of each other. Any questions on that case? All right. So last type of problem we're going to look at today and tomorrow is solving a system with 3 variables. Okay, so it's going to look something like that. 3 equations, 3 variables. Right, today we're going to learn how to solve it using an elimination approach. Tomorrow we'll learn how to do it with a matrix approach. All right, so first thing we're going to try to do is we're going to pick a variable to eliminate in two of the equations. All right? So I may say, all right, let's pick two of these equations and try to get rid of the x's. Okay, just the x's. And then, after we do that, we're going to have a system with two equations and two letters. And now it's going to be just like a problem we've done before. We'll try to eliminate another variable. And then after we do that, we're going to have an equation with just one letter. Okay, we'll solve for that one variable, and then we're going to go back and start plugging in to find the other variables. Okay, so it's a little confusing at first, but I think once we do one, it'll seem a little easier. Okay, have people done that before? Three equations, three variables? Maybe not. Okay. All right, so we got three equations and our three variables, x, y, z. Okay, before we start, when you have two equations and two variables, what were the shapes we were graphing? They turned out to be what? Lines. Okay. So it was one-dimensional. A line is one-dimensional. What kind of shape do you think this would be if we graph it? We have one extra letter, so now we're not going to be one-dimensional. We'd be graphing two-dimensional shapes. And the shape you'd be graphing is a plane. All right? So basically what we're trying to find now is where do three planes cross each other. So we have one plane, another plane, maybe a third plane. Okay. It's actually pretty easy to visualize on the computer. Maybe tomorrow, if we have some time, I can go on a website. I can type in these three equations, and it draws all three planes in different colors, and you can see exactly where they cross. And they cross in a single point. All right. For today, though, we're not doing it graphically. In fact, the graphing calculator can't even do it. There might be an app you can get for it, but just the basic calculator, you can't plug in a 3D graph. All right, so what variable do you think we could try to eliminate first?
X.
Yeah, I think we could eliminate the x's in the first and the second equation. Okay, I'm going to use the third equation to get rid of x in the second and the first. All right, let's start with getting rid of x in the first equation. Does anybody see what you could multiply the third equation by so that when you add it to the first equation, x disappears?
Yeah. Well, first equation you can multiply by.
The third equation. You want to multiply the third equation by something. So when I add it to the first, x is gone.
-2.
Yep, we're going to multiply it by -2. And I'm going to show you how we're going to write that. We're going to do -2 times the third equation. Any number that I circle represents an equation. Okay, so -2 times the third equation, and we're going to add that to the first equation. And that's going to give us a new equation. We'll call that equation 4. Right, so let's do that out. -2 times the third equation. -2x minus 8y plus 6z equals 16. Okay, multiply everything in the third equation by -2. And now I'm going to add it to the first equation. 2x plus 3y minus z equals -1. Add those up. X's are gone. What do I get for my y's?
-5y.
Good. -5y. My z's?
Minus 5z, or plus 5z,
Plus 5z equals
15.
15. Now, this doesn't usually happen, but there is something I could do here to make this equation even simpler. Every number here is a multiple of what? 5. If you want, divide everything by 5 just to make the numbers smaller. Okay? So I'm going to do that. Any question on that step? Just going to make the numbers smaller. It's not necessary, but I think it'll be easier. Negative y plus z equals 15. Okay, I'm going to call that equation 4. Okay, I'm not going to do anything with it right now. I'll come back to it, but not for a little bit. My goal is now to get one more equation with just a y and a z in it. Okay? So I already used the first equation. Now I want to get rid of x in the second equation. Yep.
Don't you mean it should equal 3?
Oh, thank you. Yeah, because we divided everything by 5. That would have really messed us up. Anyone see what I could multiply the third equation by and then add it to the second to make x disappear? Yeah. I'm going to multiply the third equation by negative 3. And then we're going to add it to the first equation. And that'll give me a new equation, which I'll call equation 5. Okay? So let's do negative 3 times the third equation. Negative 3x minus 12y plus 9z equals how much?
Negative 4. Equals 3.
What are we multiplying everything by?
Equals 24.
24, negative 3. Right? Because we have negative 8 times negative 3, so positive 24.
Yeah.
Any question on that?
Duh.
Yeah. Unfortunately, with these kind of problems, you make one little mistake and then everything's messed up. All right, so negative 3 times the third equation, and now add that to the first. 2x. Add it to the, we're adding it to the second. Sorry. Okay, 3x minus 2y plus 2z equals 15. Okay, what cancels out there?
3x's.
Yep. And my y's become
Negative 14
good, negative 14y
plus 11
plus 11z
equals
39. Good. Now what we've done is we've taken it from a problem that had 3 equations and 3 letters. Now if you focus on just equations 4 and 5, it's 2 equations, 2 letters, we'll finish it just like we've done the last few. All right, so now looking at equations 4 and 5. What letter do you want to try to get rid of now, y or z? Z? Okay. What could you multiply equation 4 by to make the z's disappear? Yep, negative 11. Okay, so we're going to do negative 11 times the fourth equation. We're going to add it to the fifth, and that's going to finally give me an equation with just one letter. And then that'll be the hardest part, and then we can get all our answers. All right, so let's do that out. Let's see, 11y minus 11z. Okay, make sure you check it as I go, because it's very easy for me to make a mistake. Minus 33. And now add it to the fifth equation. Negative 14y plus 11z equals 39. Okay, what cancels out?
11s.
Yep. What do I get for my y's?
Negative 3.
Negative 3y. And on the other side, 6. So now we can figure out what is y. Good. Y is -2. Now, what we do is we go back up to either equation 4 or 5. I would definitely pick 4, plug in, and then we can find z. Okay, let's use equation 4. -y. What's -y? 2. So I'll just put down using, so you know what we're doing. -y plus z equals 3. -y plus z equals 3. So z is 1. Now we have y, we have z. Last thing is x. Once you get one of the letters, this becomes very quick. To find x, go all the way back to one of the original equations. You can pick any one you want. Which one do you want to use? 1? Okay. Right, so using equation 1, we've got 2x plus, can somebody remind me, was it 3y? So 3 times negative, I'll do it in 2 steps. 3y, what was the next part? Minus z equals -1. So 2x minus 6 minus 1 equals -1. What's -6 minus 1? So 2x is going to equal 6, and x is 3. Okay, so you can see what happens. When you add just one letter, the amount of time it takes to solve it, it goes way up. If we were to do 4 letters or 5 letters, it starts increasing very, very quickly how long it takes. So 3 is as high as we go. Right. Any questions on the process? Many, many ways you can do this. This is the way we chose, but the process is the same every time.
So all you have to do is just to cancel out each variable if you get to when there's a while.
Yep.
Okay.
Yep. And the reason I chose way back at the beginning to cancel the x's out is I look for an equation that has a letter by itself that's positive. I didn't see that anywhere else except right there. Okay?
Is this going to be on the test?
Yep. Yep. Okay, so what I'll try to do is always give you an equation where you have a letter by itself that's positive, and that at least gives you a starting point. If you don't have that, then it can be a lot messier, especially if answers come out to fractions. But on the test, I've already made sure you will not get any decimal or fraction answers. Okay? So we're going to learn tomorrow a more efficient way to do these kinds of problems. If I wanted to write this in a matrix, all I would have to write is this. That's a matrix that represents the left side. That's a matrix for the right side. What's nice about a matrix is it's a lot less writing. I solve the whole problem without writing any letters. Okay, so I forget about all the letters, and all I have to do is write numbers.
Does it say 1y?
1, 2, 3, 1.
No, I mean on the second one.
Oh, on the second one? 1y. Yep. And all you do is put down the numbers that you see in front of the letters. And on the other side, it's just numbers anyway. Right? It's less writing. But we'll talk about how to solve a system with a matrix tomorrow. Okay, so the homework in your book. Okay, no packet, just back in your book. It's on 541. And it's 1 through 19, just the odds. Okay, 1 to 19, just the odds. As a reminder, we have our last test on Friday. Okay, it'll cover everything we've done this week, 9-4, 10-1, 10-2. And I will be after school Thursday if you need any extra help.